Okay, guys, so today we're going to be talking about waves and the electromagnetic spectrum. So go ahead and take a second, pause it, get out your Cornell notebook, and write down these learning targets. So the first thing I want to talk about is what is a wave? A wave is a disturbance in a particular physical medium or a field resulting in a vibration or an oscillation. An oscillation is when something is just going back and forth, back and forth. If I take an end of a rope and then I jerk it one way, then the other, it's going to send a wave down that rope. But the rope that I'm holding on to isn't going to be traveling down the length of the rope. Just the energy is traveling down. So the particles are not traveling where the energy is going, but they are going back and forth. All these terms here, I'm going to want you to write them down, but we're going to take a look at a figure to talk about them, of the anatomy of a wave. And same with these. A few things I do want to note is that frequency is going to be in hertz, and period is just going to be equal. It's T for period, which doesn't necessarily make sense, but that's okay. The period is going to be 1 over our frequency. So let's look at a figure here. This is what a natural wavelength is going to be looking like. This center line is going to be our equilibrium point, or equilibrium line. The bottom point of our wave is going to be the trough. The top point is going to be the crest. So this is a crest, so is this one, so is this one. How high it goes from equilibrium point up to a crest is going to be the amplitude. But so is from the equilibrium point down to a trough. So I can measure amplitude by doing equilibrium to crest or equilibrium down to a trough. Now this, if it was like water, the equilibrium point is kind of when the water is at rest. But if we see here, this water is not at rest. We see waves. And if I measure from one crest to the next crest, that's going to give me the wavelength in meters. But if I look down at this graph in the bottom right corner, I see that the same measurement gives me periods. So what's going on? The wavelength is going to be when the graph is showing me distance. How far is it in meters from crest to crest? For period, I'm looking at time. How long does it take to go from one crest to the other crest? How long does one wave take to go all the way down and then all the way back down, back up? That's going to be my period. So we're going to be looking at a couple different types of waves. We've already talked about water, slinkies, ropes. Those are the physical ones that you might play with around at home if you have a slinky or a rope handy. But today we're going to be talking mainly about sound waves and the electromagnetic spectrum and all the waves that are encompassed with that, including light. So sound waves. If I take a look at sound wave, I'll actually come back to this slide, but if I look at the air molecules, this is one air molecule. And if I were to watch it move, it would go back and forth, back and forth. It would not travel all the way down the wave. This is our waveform here. I'm going to notice that there's areas where there is very low levels of air molecules. That's going to be a rarefaction, these open areas. These really condensed areas are compressions. So this is going to be really high pressure, and this is going to be really low pressure. So that is how we get our waveform for sound, and this is called a compression wave. If I take a look at this one again, the equilibrium line is going to be where if this was an air molecule just at rest, that would be the equilibrium point. The amplitude is how far it travels in either direction from its equilibrium point. That gives me the amplitude. So if it traveled really far, that'd have a really high amplitude. The amplitude is going to tell me how loud that sound is going to be. So the amplitude, if it's a really high amplitude, it's going to be a really loud sound. If it's a really low amplitude, it's a very soft sound. And frequency, how fast it goes back and forth, is going to give me pitch. So a really high frequency sound is going to be a high pitch sound, and a low frequency sound is going to be a low frequency or a low pitched sound. So I'm going to come back to this in the next video.